Okay, section 5.5, unit vectors and direction angles. And just heads up, I assume you guys already watched the UC Scout video before you came to Zoom. So I only included the contents that wasn't really explained in depth in the UC Scout video. So I avoid explaining the content just overlapping, right? So that means if you haven't watched the video, the UC Scout video, then make sure you watch it after the Zoom. So with the instruction from the UC Scout video and from my instruction, and if you need like repetition to just listen to this instruction, and the recorded video will be uploaded this afternoon. So with both videos that you can just, you know, have all the necessary explanation, right? And again, I will remind you of that at the end again, but you still need extra practice materials that I already uploaded on the additional materials page, right? With that, and you get ready for the practice problem done this week, like Thursday, okay? So make sure with those couple of things, and then I will start the instruction. That hedgehog is enjoying bath, and it's fine. But it seems like the doggy butler looks very concerned. Okay, so now, assuming that you already know all the basics explained in the separate video, then I will jump right into the direction angle of theta of a vector v. Okay, so what's direction angle? It's an angle formed by the positive side of the x-axis and wherever the vector, given vector v is at. Okay, so then first case will be this. Okay, first case. So as you can see, the vector given vector v happens to be in quadrant 1. And the angle formed with the positive side of x-axis, and then that's technically the standard position of angle on the unit circle. It's a positive, the right side of the horizontal axis, right? And wherever the vector given. So in this case, the vector is on the quadrant 1, and from the right side of the x-axis, and then it measures the angle up to the position of the vector, and that makes the direction angle theta of the given vector v. But vector can be placed in any other quadrant too, so the other cases could be this. Then as you can see, the vector v in the second case is placed on the quadrant 4 there, and from the right side of the x-axis, and then all the way until actually you meet the vector on the quadrant 4, and then all the way, that is the direction angle there, right? So it could be anywhere, but always you start from the right side of the x-axis, and then you go until you actually hit the vector there, okay? So that way we can define the direction angle there, okay? Any question? Okay. Then direction angle theta of the vector can be depicted in more detail like this way. So usually you are given with the component form of vector. And as you can see in this example, there is a vector v is given as the component form. How do we know that's a component form? As you see, there is angle bracket, and x is the horizontal component, and y is the vertical component, right? And then if this is the case with the horizontal axis, x-axis, and vertical axis, y-axis, and then the vector v happens to be in quadrant 1, and we can measure the horizontal length, the underneath the vector as the right triangle. Then the x is the length horizontally and y is the length vertically, then the coordinate up there is indicating the position of the terminal point. So this is the terminal point here. This is the terminal point here. And x comma y will be the coordinate of the terminal point. Then with the situation that the tangent of the angle placed here will be the ratio of the vertical length y over, so it's opposite over the adjacent, so it's y over x, right? So then if you are given with all this information and you're supposed to find the angle measure of the direction angle theta, then you can utilize your calculator with arctangent. You know, this is arctangent or tangent inverse. Either way is the name of this. Then this ratio goes inside and then it's gonna give you the angle measurement later. So this is very important. The sum of the practice problem is asking with you're given with either combination of I and j or component, direct component form of the given vector, and you're supposed to find the angle measure, and this is how you can find the actual angle measure. So one example is following. Then if you are given with the vector v, the component form is 3, 4, horizontally 3, vertically 4, then we know the tangent ratio of the angle that gets the vector v is 4 over 3. So vertical over horizontal, right? 4 over 3. Then if you are supposed to find the angle measure, then with your calculator, you hit second key and tangent, then you're gonna get the tangent inverse or arctangent, right? Then you input 4 over 3 as the ratio. This ratio goes in there. Then you can test your calculator with the right setting right now, and you're supposed to get 53.13 degree. So if you get that approximation, and you're good to go. Okay, any question? Okay. Then there's a one concept, it was mentioned in the UC Scout video, but it wasn't really explained in depth, so I included it here. Okay, now, so previous case is you are given with the information of the vector, then you're supposed to find the angle measure of the direction angle. But there is another cases that you will see on the practice problem is you are given with magnitude of the vector and the directional angle. Then you're supposed to find the component of the vector. So it's backwards. Earlier, you were given with the component form of the vector, and then you're supposed to find the angle measure. But another case is if you are given with the magnitude and the angle measure, then you're supposed to find the component backwards, right? Then the next slide is explaining how we can find it. So since magnitude of the vector is nothing but the length of this vector here, and then we know the angle here, right? Then if we utilize the right triangle underneath, and this is opposite of the angle theta, and then this is adjacent, right? Then the ratio of the theta, the sine theta is opposite over hypotenuse, but hypotenuse in this case is the length, which is the magnitude of the vector. So this is hypotenuse, right? So then in that case, hypotenuse is what? the magnitude of the vector, right? So this vertical component will be cross multiply, and then it's going to be magnitude of the vector times sine value of the direction. In same manner, then the cosine ratio is adjacent over hypotenuse. And then this is adjacent over hypotenuse is nothing but the magnitude of the vector. And then this will be cosine of the direction angle theta there. And then you cross multiply. And then it's going to be the adjacent, which is the horizontal component, is nothing but. So the horizontal component is, if you manipulate this previous expression, and it's going to be magnitude times cosine theta. Okay, so then in summarize, the horizontal component is magnitude times cosine, and the vertical component is the magnitude of vector times sine. So next slide that it sums up here. So magnitude of vector, and the horizontal component is magnitude times cosine of the direction. And the vertical component will be magnitude times sine of the direction angle. Okay, so this is exactly what we've been using to construct a unit circle. So you can connect to what you've been working until now with the unit circle. So we can see next one with, so component form of any given vector can be utilized magnitude and direction angle like this way. So this magnitude will be used as a speed, airspeed or ground speed, once we go further with application problems in the next section, and you will see the magnitude will work as a speed. Like it could be airplane speed or boat speed or car speed that we're gonna figure out on the application word problems later. And then usually they're gonna give you the direction angle as the direction of the vector, and you can utilize this formula so that you can come up with that, the component, because the component itself, whether it's a horizontal or vertical, will be the answers for the application problems. So you will remember this part later once we hit the sections with application problems, okay? And the next slide is just handwritten summary or the logic behind how we can come up with the vertical component B with magnitude times sine theta, and the horizontal component A is magnitude times cosine theta. So in this case, theta indicates the direction angle. Okay, then let's do examples really quick. Okay, what is the direction angle of the vector V? It's 5i minus 2j. Okay, so previous section we learned how to rewrite component form of a vector into combination of I and j. So this is nothing but a combination of I and j. So this is the value that goes with I is a horizontal component. Value goes with j is a vertical component. So this is nothing but vector v and angled bracket, and this is going to be 5, and the vertical component is -2, so -2 here. Okay, then you can rewrite the combination of INJ form of the component of vector V into this 5, -2 inside of the angle bracket. Then with it, and we can draw the vector. So if you unit vector the vector V, it's gonna start from the center here, and horizontal is +5. So you go to the right by 5 units here, and the vertical is, notice this is negative. So it's gonna be -2, so 2 units down. So it's here, 2 units down. This is where your terminal point is at. So now we notice that quadrant 4. So the vector V is placed at quadrant 4. Then now we can find the direction angle from the right side of x-axis and all the way up to where the vector is placed at. So this is theta. But notice the inscribed right triangle that we're going to use under the vector being the hypotenuse is here. So now this is right triangle under here. So then this is 5, and then this is -2. So that means the ratio of tangent of the direction angle theta prime, notice that I'm using reference angle theta prime in green there. So tangent of theta prime is vertical -2 over horizontal +5. Then next step, we will use arctangent or inverse tangent, tangent inverse of -2 over 5. So this one goes in there. Will give you the value of the prime, the theta prime. So if you are using your calculator, you type second key, tangent key, and -2 over 5, and you're supposed to get approximation of -21.80140 blah blah blah. So it's going to be round up to -21.8. Then it makes sense because this theta prime is supposed to be what? Negative from the right side. So it makes sense, right? Then also, as we notate, the direction angle is always from the right side of the x-axis and then all the way positively up to that point. So then that's nothing but what? Coterminal angle. So coterminal angle of -21.8 is 360 minus 21.8, which is what? 338.2. So it's this problem, and some of them, like answer choices will give you directly -21.8, or you might see positive 338.2. So either way, so you have to be really carefully examine your answer choice for the multiple choice problems. So it's the answer is either way. So either this or the other, right? Okay, so that was all for today. And